Good Tuesday or Wednesday class. I'm not exactly sure which day it is, but today I'm going to give you a little direct instruction on waves. I know it's tough without me being there, but I thought I could together a little something and you could watch it and get some notes. So you're going to need your composition notebook and a pencil. I will be checking these notes when I get back to class, and who knows, there may or may not be a quiz on this information. Wink, wink. You know that I oftentimes let people use notes on these supposed quizzes. So if I were you, I would take the notes that you see fit. You don't necessarily need to copy word for word, but you need to have some information gathered so that you can be successful both on the test and the quiz. Okay, so let's get started. Today we're going to be talking about waves. Waves are a vibration or a disturbance that carries energy from one place to another. Uh, so this energy moves. Think of a slinky. If I stretched a slinky between me and, let's say, Ashley, and we held it, it wouldn't move. But once Ashley moves her end, the wave or the slinky is going to bounce up and down, carrying that vibration from one place to another. Now, this is important right here, guys. Waves will continue to travel in a straight line until they come into contact with another object. We call these other objects mediums. Make sure you know that. Definitely write that down. Pause if you have to. A wave will go into a straight line until coming into contact with something else. It will go on a straight line forever and ever and ever. Um, most waves will keep going until they hit something. Sorry, I repeated myself. Light waves, for instance, can travel through space. Those waves will go on and on and on until they come into contact with another planet, maybe a moon, possibly an asteroid. But if I teach you nothing else, it's that waves will go in a straight line until they come to contact with something else. Now, when they come into contact with this other thing or these mediums, it kind of depends on what they hit as to how it travels. So there's two types of waves. Mechanical waves, right here, are mechanical waves that require a medium. So if you look down here, water waves like an ocean, they require the medium of wind to carry them and water. You have to have the combination of wind and water to make this mechanical, think mechanical or movement of a wave. Likewise, sound waves are caused by a vibration that travels from my mouth into your ears. So I'm making noises using my voice, and it is vibrating magically in this hospital bed through this computer. And when it comes out, it's affecting the small little hairs in the inside of your ears, and you are able to hear it. Some people that have hearing issues, they can still make these sound waves, but they can't often hear them. Now, electromagnetic waves are the waves we're going to be focused on most of the time. Electromagnetic wave is what it sounds. It has both electric and magnetic qualities. It is caused by the change in the magnetic field. Electromagnetic waves do not require medium, so they travel a lot farther. So if you look over here, light, micro, infrared, X-rays, ultraviolet, radio waves, all of those do not require a medium, and they will travel a whole lot farther. Most of these, not all, will travel in and out of the vacuum of space as we refer to it. So for instance, light waves can go in and out. Now the cool thing about Earth is we have an ozone layer surrounding it that keeps some of these more harmful rays out. And we'll talk about that a little bit farther in this PowerPoint. I would definitely write down what an electromagnetic wave is and maybe list these electromagnetic waves. If you need to pause, do so. The beauty of us doing this in a video is you can take as much or as little time as you need. Okay. So I'm going to skip over here. Waves do a variety of different things when they come in contact with a medium. When we talk about transmission, this means it just goes straight through. So think about a laser through a piece of glass. that laser is going to go straight through that piece of glass onto the other side. Okay. The next type is reflection. In a mirror setting, it is going to reflect off of an object and go in the direction in which it came. Sometimes it will go in a straight line. Oh, I couldn't do that. And sometimes it will go sideways. Refraction is, think of a prism. If I take a laser and I point it through a prism, it is going to refract into a different direction. Diffraction, think of this as a flashlight. My light wave is going to come here and it's going to diffract in several different directions, allowing that light to move out and cover more of a surface area. Absorption is exactly what you think it is. It's when light is absorbed. So think about wearing a black shirt on a sunny day. The heat is absorbed by that black shirt because it cannot transmit through it. Darker colors and darker things absorb more of visible light. Scattering, again, think of a disco ball. It's going to scatter the light in multiple directions, and it's kind of you're not going to know where it's going to go. This is probably the least common here, is the scattering. Two of those are really important for what we're talking about. Refraction, again, here's the prism. I'm shining my light into the prism, and it is refracted in a different direction. This one is showing all the rays of visible light. Guys, color is just visible light, and this kind of proves that. When visible light hits something, you see these different colors based on their wavelengths and how big their wavelengths are. Refraction causes the deflection of light. I'd write these two down. Reflection, that one should be pretty simple for you. If you've ever looked in a mirror, you know that you'll be able to reflect your own image back into that mirror. You can see yourself. Similar to this car, being able to see the street lights behind it. Here's the electromagnetic spectrum, and it goes from the biggest wavelengths to the smallest. Now, this goes, the biggest wavelengths to the smallest. Now, these are the less harmful waves, and we get over here into the more harmful. I want you to copy the top part of this into your composition book. Radio waves are huge, and that's why they're able to go into space, hit deep space satellites, and come back in. Microwave, you guys know what we use those for. We heat up our food. So these waves make a heat and are able to be used and harnessed. Again, they can go in and out of space. Infrared is the ability to see things based on their heat. We have to use infrared goggles. We do not have infrared capabilities as the human race. There are, in fact, some species that see infrared. Bees, for instance, see infrared, and that is how they're able to locate pollen that you or I cannot see with the naked eye. So in this entire spectrum, visible light, this is all we can see. It's the only part of this wave spectrum that we can see. Roy G. Biv. Write that down. Roy G. Biv. That's the colors of the rainbow. So red has the biggest wavelength, and ending with blue having the smallest. Now we get over here into ultraviolet, X-ray, and gamma rays. This becomes more harmful radiation. Ultraviolet, it sneaks through, and I'm going to switch back and forth there. Ultraviolet sneaks through the ozone layer. So you see this is signified by like an open window. Only partial amounts of infrared are able to escape through the ozone layer. This is the stuff that gives you skin cancer. So these ultraviolet rays that do harmful things to the skin. X-rays are completely closed off because of the ozone layer. Excuse me. I need a drink of water. So we only are exposed to those if you break a bone. And it's a good thing because too much radiation causes cancer, similar to the ultraviolet here. And gamma rays, I know you guys are thinking about the Hulk. And we're true. These are, they use gamma rays in cancer treatment. And they're highly, highly toxic and full of a lot of energy. The smaller they are, the harder it is to get through our ozone layer. That's why it's important to keep our ozone layer intact. There is some holes in the ozone layer that scientists are concerned will increase global warming, but also allow in these harmful rays that can hurt us. Okay, so now waves carry energy into a medium, and we were talking about that. So we talked about if you put a laser light through a piece of glass, it will transfer through and you'll see that same laser beam on the other side. But I want you to look right here. Look at this laser pen, and this is a translucent block. Think of a translucent block as like the cap of a water bottle. Translucent means not completely see-through, kind of opaque, but it's not clear. So what's going to happen is this translucent block is going to absorb, let's look up absorb, it's going to absorb most of that light. So it's going to absorb it within its cap and then only transmit partial amount of light to that chalkboard, diffracting. So you'll no longer see a beam of light. You'll see a bigger red type spot on this chalkboard where the translucent block has absorbed it some. You definitely, guys, this is going to come up again in your test and on your interim. You need to know that some things don't transmit perfectly. Some things absorb partial amounts of light, and then they diffract that remaining amounts of light into a different pattern. Okay. I'm going to have you read through this on your own if you want to pause it for a second. It's something I've kind of already talked to before. Light continues in that straight line until it comes into contact with something. That's the main thing. Electromagnetic waves don't require a medium. They will just keep going and going and going into space. So think about the radio. The radio station plays music. They send this wave into space. It hits a satellite, and then it is reflected or refracted back into Earth, into our car stereos. It has to have a medium to take it out of its straight line. Do not forget, it will continue in a straight line. I know I'm saying it over and over again, but again, you're going to see this in tests, on the interim. It's something that you're going to need to know. Okay, how do we use light waves to explain things going on with the planet and stars and the sun? So you guys know that the sun is a huge ball of hydrogen gas, a gigantic star that's burning constantly. We don't always see the sun because the earth blocks its rays. So I made a little drawing. Don't laugh. I know you guys are laughing inside already. So on this side of the planet right here, it is daylight. So let me take a shape here. We'll start here. So in this side of the earth is daylight. Whoa. You guys get what I'm saying. The sun is you are able to see it. On this side of the earth itself absorbs the sun's rays. It doesn't transmit them. So when the earth is faced away from the sun, we don't see it. Doesn't mean that it's not still bright or shining. It's just that earth is able to absorb those rays and that heat, and we don't see it while it's night. As the earth constantly rotates, you get into different kind of scenarios. Again, here's my moon. The moon is not a source of light. It only glows in the night sky because the sun's electromagnetic rays hit it and refract it to Earth, giving it a yellow color or making it seem as if it's a source of light. But in reality, it's just a big rock. We don't see the stars during the day because the sun is the closest star to us. It's the closest star to Earth. So when we're facing it and it's daylight, like here, all of these stars are behind it on this side. So, hi, my kids just walked in. let me wrap up my thing 1 second. So we don't see these stars on because they're not as close as the sun. But again, when we're facing away and it's night, you'll be able to see those stars. So go ahead, take a minute, read through this. You will have to do an open response answer on this. So you guys take a second. My babies just walked in. They give me a hug, tell me they love me. Aw, hey, sweetie, I'm almost done. There's two things you definitely need to know about how we use stars. First is scientists use the light waves from stars to know the distance between things. Cepheid variable stars are stars that shake constantly, and we compare those to Earth, and we can see the distance between Earth and other stars and planets. We use these stars very, very proactively to know distance between things in our Milky Way. Obviously, we can't use a typical measuring tape. You will need to know what a Cepheid variable star is. You have to write this down. It'll be on your interim and it will be on your tests. And last but not least, we classify stars based on their color using the absorption spectrum. Again, you're going to need to know what the absorption spectrum is, and you need to know that it is what categorizes the surface temperature of stars. Guys, this is super important. Again, on your test, on your interim. Which, Caitlin's standing right here. Which of the color of stars do you think burns the hottest? Red. Red. Wouldn't you guys think red? Because red means hot. Oh, Violet in the back said it's blue, and she's right. You might think red because you think red and fire, but truly, the hottest stars are blue, and they gradually change color to the coolest stars, which are red. Okay, guys, I want you to go back through. Listen to this again if you have to. Make sure you have this information in your notes. You may or may not have a quiz on this. I'm guessing you will see a quiz on this by Friday. I will attach both the keynote and this video to Schoology so you have it to access, but make sure you put those notes in your composition book so I can check them when I get back. Again, I don't know when I'm going to be back, guys, but keep up with your work. Keep up with your notes. We only have 4 weeks left, and we have to get through waves, and then we have to get into electricity. So do your best. If you have any questions on any of this, email me. Ask me questions. Ask your sub. Ask Miss Atencio. Ask Coach Hills. Again, email me. Maybe I'll address it as a whole class. I plan on doing some of these videos so you guys can get more direct instruction, and so you're not just doing worksheets. So make sure to use your time wisely. I miss you horribly. Have a great day.